Welcome to Atmospheric Tales, a podcast that amplifies stories and experiences related to air pollution and climate change from around the world. I'm your host Shazad Ghani, and welcome to another episode of Atmospheric Tales. On this podcast, we invite guests to discuss various themes connected to air pollution and climate change, such as science, policy, journalism, activism, and more. Please reach out to us if you would like to suggest episode topics, guests, or be an interviewer on one of our episodes. Our contact information can be found on our website, atmospherictales.com. Our interviewer for this episode is Anna Tobler. Anna is a PhD student at the Paul Scherrer Institute in Villingen, Switzerland. She uses advanced aerosol instrumentation and source apportionment tools for identifying and understanding the sources of air pollution based on the chemical characteristics of the measured aerosols. She has worked on measuring and understanding sources of air pollution in polluted cities such as Krakow, Poland, and New Delhi, India. She is on course to finish her PhD in a few months, and I'm glad that she could take some time off from her writing to join us here today. Our guest today is an atmospheric chemist who focuses on the chemical characterization of atmospheric particles in urban and remote areas through a combination of measurement and modeling methods. She recently finished a scientific visit to the Paul Scherrer Institute in Switzerland and is currently a guest scientist at the Max Planck Institute for Chemistry in Germany. She finished her chemistry study at the Department of Chemistry at the University of Zagreb in Croatia and then received her PhD from the Department of Chemistry and Biochemistry at the University of Colorado Boulder in the US, where she was a fellow at the National Center for Atmospheric Research. She pursued postdoctoral research at the Max Planck Institute for Chemistry in Germany and the Michigan Technology University in the US, after which she joined the University of Rijeka, Croatia as an assistant professor. Over the last decade, she has worked on air quality projects in the United States, Mexico, Germany, Portugal, and Italy. She is now using her expertise to tackle air pollution in Eastern European countries. In addition to her scientific work, she also spends time raising awareness of air pollution in the Balkan region. I'm excited to welcome our guest, Dr. Katja Džepina. Welcome to the show, Katja and Anna.
Thank you, Shaza, for the introduction and for hosting us. Hi, Katja.
Hi, Anna.
Your work has spanned across multiple countries in North America and Europe. Can you tell about your journey through these various countries at different stages of your career and what were some of your motivations along the way?
I started my scientific journey at the Ruđer Bošković Institute in Zagreb, Croatia, where I worked with Professor Leo Klasinc. And after a few years working there, I went to pursue a PhD in Boulder, Colorado. Originally, my mentor Leo sent me for a few scientific visits in Boulder, Colorado, and there I was approached if I'm thinking about the PhD in America, and I applied, and that's how I got to Boulder, Colorado. It was really incredible to study atmospheric chemistry in Boulder because I worked with my mentors were Saša Madronić of National Center of Atmospheric Research in Boulder, Colorado, and Jose Luis Jimenez of University of Colorado at Boulder. So I had a chance to have two mentors, which are arguably some of the best world modelers and experimental scientists for aerosol chemistry. It's been an incredible journey there. Then, of course, if you wish to stay in academia, which I wanted to, after your PhD, you go to a postdoc, and I joined the particle chemistry department at the Max Planck Institute for Chemistry, where I continued working with the same aerosol mass spectrometry experimental techniques as during my PhD. After that, I wanted to deepen my knowledge on the molecular level of particles, or the molecular chemical composition of atmospheric particles. So I joined the group of Professor Lynn Mazzoleni at Michigan Technological University. And Lynn, she's a very well-known expert on ultra-high resolution mass spectrometry, which pretty much gives you the molecular fingerprints of the species of organic aerosol. And the project there was super exciting because our research station and where we collected our data was at the Pico Mountain Observatory, which is at the top of the volcano in the middle of Atlantic Ocean. at the Pico Island of the Azores archipelago. So we had a chance to study the behavior of aerosol in the free troposphere. And after that, I went back home, back to Croatia, where I used to be a professor at University of Rijeka. While in Croatia, I focused on two things. First, my focus was on the aerosol exported from quite polluted areas of Europe, such as the Po Valley in Italy. And these air masses, they reach some of the Croatian islands, so we were collecting some samples there. And after that, my friend and colleague from the University of Colorado at Boulder, Krista Hazenhoff, organized a workshop in Sarajevo, Bosnia and Herzegovina in February 2017, and that's how my involvement in the work in Bosnia and Herzegovina pretty much started. From that workshop, we brainstormed and then conducted the first study, longer-term study throughout about 3 months of winter in the winter of 2017-2018 in Sarajevo, Bosnia and Herzegovina, to try to understand the sources of pollution in some of the most polluted areas of Europe and the world, which Sarajevo unfortunately is today. And motivation for my path is, I think all of us in the science, we really like discoveries. So main motivation is the thrill of discoveries, of doing the new work every time you encounter a new problem. And also the very big picture, I think, for each of us is to help the societies in bringing the clean air, which is one of the most fundamental human rights, to each society we work in.
You mentioned now a few times that you're studying aerosol, and aerosols are an important part of air pollution.
Mm-hmm.
Can you maybe tell our listeners a bit more about what aerosols are and how you are studying them, and how this can inform us about the sources and processes that cause air pollution?
So strictly speaking, the definition of aerosol is liquid or solid suspended in the gas. So in the terms of the little particles we have in the Earth's atmosphere, so it's the solid or liquid particles suspended in the Earth's atmosphere. So strictly speaking, it involves both the gas and particle phase. However, when we scientists talk about the aerosol, we always refer to little particles in the air. Those particles have different characterizations depending on their characteristics you wish to look at. We often talk in terms of the sizes, and they can go from a few or several nanometer size, which are the freshly formed particles, to the very, very big sizes from maybe 10 or 100 micrometers, which would be the dust, which we can see with our own eyes, right? Every week when we clean our house or daily, we see a lot of those. Particle size is very important because it influences their ability to travel throughout the atmosphere. Very small particles in so-called accumulation mode, which is some hundreds of nanometers, they can travel throughout the atmosphere for a few weeks, sometimes even longer. So in that way, they can transform in the atmosphere, and something that was emitted from, let's say, the burning, the forest fires in America can reach Europe. The other very important part of the particle size is their influence on the human health, because very large particles, such as dust, they cannot enter the human organism. They cannot pass through our nose. And also they very easily settle down under the gravitation within about some hours or up to a day the most. However, very small particles can very efficiently enter through the nose to our upper respiratory system. And then the smaller they get, the better they penetrate our lungs, our alveoles of the lungs, and very small particles, which we call ultrafine particles, which are smaller than 100 nanometers, can even enter the human bloodstream. Why is this important? Well, if you have some very toxic species adsorbed or formed within the particles, such as polycyclic aromatic hydrocarbons. Once they enter our organism, they can cause adverse health effects. So we know that mainly what these small particles, and when I say small, they should be smaller than 0.5 micrometers. We know that they're very nicely correlated with adverse health effects such as heart disease, lung disease, cancer, etc. Now, I also mentioned one other quality, let's say, of the particles, and that's their chemical composition. It's not the same if you breathe in the little particles which are pure water, or you're breathing in particles which have a lot of polycyclic aromatic hydrocarbons as a part of them. So what we do, especially with aerosol mass spectrometry and many other techniques people have developed, is try to distinguish these things. What is the number of particles, what is their size, and what is their composition? Besides the effects that I have already mentioned, particles are a very big part of today's climate change, and they're the biggest uncertainty in their influence on the warming of the atmosphere. We actually are still not absolutely certain if they are aiding to warm up the atmosphere or they're actually cooling down and thus slowing down the effects of greenhouse gases such as CO2.
Air pollution is also a big problem in not just Asian but also European cities. Can you tell us maybe a bit more about the polluted European cities that you have worked in and the major sources of the air pollution in those places?
Mm-hmm. Well, historically speaking, I was born and raised in a country which does not exist today. The name of that country was Yugoslavia. And the place that I have spent last years researching is a part of that former country of Yugoslavia. So Bosnia and Herzegovina has some of the highest air quality problems in the Europe and I would say in the world too. But it's not only Bosnia and Herzegovina, it's quite a bit of countries from former Yugoslavia nowadays are experiencing some of the worst air qualities of the world. Actually, on several occasions last winter, we had Sarajevo registered as the most polluted city in the world. It was not only Sarajevo, Bosnia and Herzegovina, it was also Belgrade, Serbia, it was Skopje, Macedonia. These are the countries that they are geographically a part of Europe, however, they are not a part of European Union. So some of the laws and regulations that are very customary applied in European Union do not apply to those countries. At the same time, they are positioned in the very heart of European Union and they are surrounded by European Union countries from all sides. So I believe that we should, in the future, right now we are doing research on the specific city, on Sarajevo, Bosnia and Herzegovina, and in a very near future, next winter, we just finished writing a proposal that would focus on 6 cities in Bosnia and Herzegovina. What I find really important for European Union and the world actually is troubleshooting and understanding the role this air pollution plays in the air quality of European Union and does it have the influence on the global scale for the climate change. The main reason we have this urban, highly polluted hotspots in the Balkan region, I believe is the geography and the type of life the people are leading. So, for example, Sarajevo in Bosnia and Herzegovina is, strictly speaking, geographically speaking, it's the mountainous town because it's situated 550 meters above the mean sea level, and it's surrounded by the mountains. And this is a very typical story of all the Balkan cities. So they are situated a little bit higher in the altitude. I don't think many of them are actually mountains. I believe, geographically speaking, you need to be above 500 meters above the mean sea level to be registered as a mountainous town. But the Thing is that they are in the valleys of the mountains surrounded by hills or mountains. And then the other part is that in the winter, in such places, you very frequently experience the meteorological phenomena called temperature inversion, where you have the warm air sitting above the colder air, which is restricting the mixing of that layer of the atmosphere. Meaning that from one day to another, as the emissions are getting in this valley of the city, they're just staying there. The other part of the equation, so we cannot blame geography on the sources of energy that people are using. So the other part of this equation, I believe, are the solid fuels people are using for the heating in the winter months, as well as the vehicles fleet, which is really heterogeneous. While there may be or there do exist some regulations, they are not strictly enforced for the cleaner cars or the engines that are not emitting all kinds of junk. So when you pair up the households which are using, for example, in Sarajevo, a lot of wood for heating and the heterogeneous vehicle fleet, and when you have the situation where, for example, temperature inversion occurs, you get in the situations where the daily averages of PM2.5 or particulate matter with an aerodynamic diameter smaller than 2.5 reaches 400 or 500 micrograms per cubic meter for daily average easily. Some years ago in Skopje, Macedonia, northern Macedonia, in the winter of 2017, they reached 1,200 micrograms per cubic meter. So Sarajevo is the city which doesn't have a lot of industry. Unfortunately and tragically, vast majority of industry was destroyed in the war. However, then in Bosnia and Herzegovina, you have some cities that are also big industrial hubs, which are also undersampled and under-researched on. For example, you have city of Zenica, which has a huge steel-making plant. And then you have a city of Tuzla, which has the largest Bosnian power plant. All of the industry in Bosnia and Herzegovina is powered by the coal. So then in those two cities, Zenica and Tuzla, I would say the main sources of emissions, which again gets accumulated in the atmosphere, would be the coal burning.
And would you say that the people in these cities are aware of the poor air quality and its possible side effects?
I think they're very well aware that the air quality is extremely bad. People get sick throughout the winter. People are really complaining throughout the winter when those hazardous levels are reached. I know of a story where my colleague and a friend, she went to visit a friend in a certain part of the town that she hasn't been before so much during one day of the high pollution. She actually got lost because she couldn't see ahead of herself. Somebody had to help her find the house she was looking for. People are very well aware that it's very bad. I'm not sure that they understand fully the direct correlation of aerosol or little particles in the air with the adverse health effects. Some of the things we take for granted, like our education and the level of knowledge, how it's important not to reach the hazardous levels, I don't think it's a part of general knowledge, maybe in Bosnia and Herzegovina. They're very well aware that people are getting more sick and people just don't feel well and cannot function so well on the days with the high pollution. Another really extreme story is a friend of mine. He took with his wife, they had two little daughters. They were a few or several years old. And they went to one of the mountains around Sarajevo, which is a skiing resort, for a week. And when they were returning in Sarajevo, there was a big pollution episode going on. So the moment he drove from higher up into Sarajevo, his little daughter started throwing up. And we as a scientists know that the high levels of particles in the air, they are the worst for young and for elderly. So for me, it was the clear reaction of a very young organism that doesn't yet have such a strong immunity to the pollution it's experiencing. I'm not sure if they directly know all the hazardous effects of such a high pollution episodes on the health. And I believe that the consciousness on this is increasing from year to year.
You also mentioned that especially in winter, you have a lot of residential heating from domestic coal or wood burning. Can you give us some examples of how policymakers in the region are trying to solve this issue?
I think at this point, it is not clear fully what the sources of pollution are, and there is a lot of discussion about that. We hope to bring that awareness very soon with our papers, because what our work has shown is that in Sarajevo, most of the aerosol are coming actually from wood burning. The wood burning in Sarajevo is connected to the households which do not have the access to centralized heating system. There is a good part of the city of Sarajevo which is connected to centralized heating system. And of course, then they have the radiators and they do not need to use any solid fuels for their houses. However, there is a lot of houses being built, especially towards the kind of in the hills of Sarajevo. So you have the valley, and then of course the population is spreading up the hills too. But many houses spreading across the hills, they are not connected to the centralized heating system. And then those houses or apartments are being built with, they are not using gas because it seems to be more expensive for them, but they are building the houses so that they can use solid fuels with the stoves that usually then go, according to our findings, they are mainly using the wood. So I would say that the vast majority of that pollution comes from household heating, which is using the wood as the energy source during the winter.
By the virtue of understanding and recognizing a problem, scientists often need to communicate the problem to a general public to raise awareness. How do you balance your role as a scientist, communicator, and activist?
This is an interesting question because I never considered myself an activist, truly. Of course, I have a deep passion for making a change, and I think each one of us working in science, we want to have an impact from local to global level, of course. Maybe for the Balkan region, my background of being a translator during the war in the 90s in Croatia and Bosnia has a part of it, because I saw a lot of human suffering, and our role was such that we do not interfere in the process. So I often felt helpless. So I think right now I want to use my skills and knowledge to raise the awareness of what's happening. One thing that was one of the main objectives of my work in Sarajevo in the winter of 2018 was to bridge the lack of networking between the scientists and the researchers and institutions in Bosnia and connect them with the state-of-the-art institutions worldwide. I truly and profoundly believe in the power of science to resolve the problems, and also we are very lucky to have networks we have. I have my network from many years from my PhD onwards. However, after the war and under the very adverse economical situation, I do not see the state-of-the-art science being developed with a strong pace in the Balkan region. So I think, if you may call it activism, my main activism was to connect people from Sarajevo with the world network of state-of-the-art scientists so that they can continue developing themselves as a scientist, and that through that knowledge of what's going on in the atmosphere, we can all together bring a change.
Through your journey, you must have faced difficult choices and demoralizing moments. How do you keep yourself motivated through everything?
Science, by definition, is hard, and what we do is we always go into answering the questions we do not know answer to. And that's very interesting, because when you are in the college or you're in the high school, or no matter how well you excel, when you are asked a question, usually, as they say, the answer is at the end of the textbook, right? But here we go into the questions where we don't know answer to. So that's something one needs to get used to. Honestly, my main motivation is my community. I have never met such an incredible bunch of people like atmospheric scientists. I think all of us are so willing to help each other. There is always the door you can knock at to ask a question. So our community is the biggest source of motivation for me. And of course, being willing to answer the question you have set out to answer. It's also accepting that the best science, it gives you answers that you looked for. However, it poses many more questions along the way. So you just need to get used to the fact that, yes, hopefully, I will be able to answer the question of sources of pollution in Sarajevo and Bosnia and Herzegovina. But besides answering that question, I will have at least 10 more questions I don't know how to answer, which could be the source of future research. My PhD mentor, Sasha Madronic, he told me one of the first times we met, he told me, Katja, I do this because it's fun. Once it's not fun, I will stop doing it. He's still doing it. So I think we all find the great joy in finding the ways to answer the questions that we are faced with.
With that, I would like to thank you, Katja, for the very interesting insights into your work. Thank you for answering all the questions.
Anna, thank you so much for your fabulous list of questions. And Shazad, thank you so much to you and the entire team of Atmospheric Tales. I think it's fantastic work that you do, and keep up with it.
With that, I would like to thank our guest Katja Džepina and our interviewer Anna Tobler for joining us on this episode of Atmospheric Tales. We would like to thank Adrian and all our other community members for suggesting questions for this and past episodes. Follow us on Twitter and Facebook to ask questions to our upcoming guests. Thanks for tuning in. Make sure to subscribe and share.